This demo shows how trust and verification are established across the different components in this innovation track. Throughout these examples, organizations exchange data and documents as verifiable credentials. Each credential is cryptographically signed by its issuer. This allows the receiving party to verify both the authenticity of the data and the identity of the issuer. In this track, existing trust infrastructures are used, specifically IDA's Q seals based on X.509 certificates. These provide a legally recognized way to sign and verify data. To enable this, the plan was to use a Cloud Signature Consortium, or CSC API to request remote QSeal signatures with private keys securely stored at a qualified trust service provider. In this track, this functionality is implemented using the Digidentity Remote Signing API, as support for this specific CSC functionality is still evolving. This also highlights how critical it is that private key material is securely managed. These keys should be stored in secure environments such as hardware security modules, ensuring they cannot be copied or misused. In addition to secure key management, organizations need a way to determine which issuers and trust anchors they trust. For this purpose, trust lists can be used as an input to these trust decisions. The trust list used in this innovation track is based on the ETS-ITS 119612 specification. In this innovation track, the FIDES trust list is used as an example of how trusted parties can be defined and shared. This trust list is openly available and can be accessed and reused by different participants. At the same time, decentralized identifiers are used to resolve organizations and retrieve their public profiles. From these profiles, verification methods and relevant credentials can be discovered and validated. Together, this creates a flexible trust model where organizations can verify each other based on their own policies. In practice, verifiers or relying parties can configure these policies themselves using trust lists and other sources to determine what they accept. They can decide which issuers, credentials, and trust frameworks they trust. And they can choose to rely on trusted public or private parties to define or manage these trust frameworks. All components used in this track are based on open standards and supported by open source implementations. This makes the approach transparent, reusable, and interoperable across ecosystems. This demonstrates how existing trust infrastructures and new decentralized technologies can work together to enable trusted digital interactions at scale.